have a problem that was motivated by a recent SMO senior problem, and let's just recast what we're actually trying to do. We have a rational function where we're given a slant asymptote, sometimes called an oblique asymptote, and also we're given a stationary point. Now the stationary point just means that's the x-coordinate of where you have a horizontal tangent line. It's called the stationary point, I think. That's in Singapore. I don't know if that's a common term, in the U.S., but in any event, it just means y prime at 3 is equal to 0. So we're supposed to find A, B, and C. That's the same thing as find the equation of the rational function. Find A, B, and C. Those constants, once they're found, that will completely determine this rational function here. So find A, B, and C. Okay, now this very first statement is very, very important, and I'll write down what this really means here. You're actually given that 5x minus 7 is the quotient when you divide x minus 5 into the numerator. Now the reason is, if you just think about the way I've labeled y right here, the limit, and this really is a definition. This is the definition of what we mean by oblique asymptote or slant asymptote. The limit is x approaches plus or minus infinity. Okay, I'll put plus or minus. That's minus infinity is unbounded to the left, right? So we'll do plus minus infinity here. Okay. Of y, as I've labeled it here, actually equals. You see, now notice when you do the division, you're dividing by a linear term, okay? And so that means your remainder has to be a constant term. In other words, d has degree, this has degree 1, d, any constant can be thought of as a degree 0 polynomial. And so this would be equal to 5x minus 7. And literally, that is your definition, or you could place this object right here, and when you do the limit, if you get 5x minus, I'm sorry, let me just, I'll quit talking. Let me just write this down first. 5x minus 7, okay? Now, what I'm trying to say here, can't talk and write at the same time. Notice that since d is a constant, as x gets really, really large in either direction, as x approaches plus infinity or minus infinity, this term right here would just approach 0, right? You have a constant divided by a bigger and bigger number. So in the limit, this quotient right here, the d over the x minus 5 would approach 0. And that means the line 5x minus 7 is a good approximation for this rational function for large x in both the negative and positive direction, okay? So that's an important thing. And again, this, if you think of this as being your y or this as being your y, it's the same thing. This would be the result of a long division, remainder, divisor, all of that. And this would just be the definition. If you were to start with this and you could show that this was true, that would mean that that would be the slant asymptote. But you see, you're actually given the slant asymptote. So that's why we're writing it down here. Okay, now this next part here is just finding the derivative. Again, the derivative at 3 has to be equal to 0 because that's where you would have a horizontal tangent line. That's what it means by stationary point. And so notice the derivative of 5x minus 7 is certainly just 5. And if you think of d, this part right here also being the same thing as d times x minus 1, x minus 5 raised to the minus 1 power. Okay, when you differentiate this by the chain rule, you're going to get, put minus 1 there. If you differentiate this object, you get this. It's a well-known rule. You subtract minus 1 from minus 1, you get minus 2, okay? And then the minus also, it's just part, this is the chain rule. Taking the derivative of this by the chain rule leads to this statement right here. Okay, now we're given that the stationary point is 3, right? And so we substitute 3 in right here, and you solve and you get d is equal to 20, okay? So that's good news because we now know the value of d, which is all we needed to know to determine the rational function. And then after some algebra, you end up with this. Okay, and again, I left out the algebraic step, but the step is very simple. You just multiply 5x minus 7 quantity times x minus 5 quantity, and you end up with this. That's very easy to verify. Okay, so this is the answer to the question. Now, I went to the trouble and had some software graph this, and so you can take a look and see if you trust this. But there's our rational function. Okay, now notice this vertical asymptote right here would be x equals 5. Let's see, is that scale done there where you guys can see? Yeah. So x equals 5 is vertical asymptote. And again, y'all, we are done with the problem. Seeing is believing. All right, but x equals 5 is this vertical asymptote, okay? And then also, if we go a little bit further, remember 3 was our stationary point. That's why we substituted 3 in right here to get d equals 20. But you can see right here, this is a scale of 5, right? 5, 10, 15, 20. So it's very easy to believe that horizontal tangent line happens at 3, right? That would be about 3 right there. Okay, you got a horizontal tangent line or a stationary point right there. This is 5, so 1, 2, 3, right? 4, 5. Okay, very good. And then 5x minus 7, that certainly looks like the point 0, negative 7. Let me draw an arrow there. That would correspond to the point 0, negative 7. Okay, so you see that is the y-intercept of the slant asymptote. Okay, and again, this is I just let some online software graph it because my scaling would be substandard and not worth showing you guys. So again, 0, negative 7 comes from the fact that 5x minus 7 was specified as our slant or our oblique asymptote. Let's see what else. Everything else looks good. You see how the graph of the function is trapped between the vertical asymptote x equals 5 and this line right here, and I'll write the equation for this line is y is equal to 5x minus 7. Y is equal to 5x minus 7. And if you go down further, you can see the same kind of behavior happens down here when y is negative. Okay. Again, horizontal tangent line or stationary point at x equals 3. And let's see, what else? Anything else to say? We do have one other stationary point right over here, but we didn't really, all you need is one stationary point to get this done. Okay, it looks like the other stationary point might be around 8 or let's see, 7 maybe, 7. But in any event, that's that. We did recover the original function by, again, basically 2 ideas. This limit notion of what the slant asymptote is, and also what does a stationary point mean? Well, it's just the value of x where you have horizontal tangent line, okay? So that's why we could substitute that into our derivative of the result of the long division. Solve for d, substitute d in, done with the problem. Hope you enjoyed.